All right, pre-algebra kids, hopefully you've sat down and done your review. This is your companion video with your answers. So, got our first test. I know we jumped around a tad right there in the beginning. We're going to go back to the fractions and the decimals and the percents shortly, but we're going to focus on integers, real number systems, squares and square roots, and fraction operations. Okay, so let's get started. Name all the subsets of real numbers to which each value belongs. All right, so I'm going to pause the video and the music. I'm going to write this out and then we'll go over it. Okay, hold on, here it comes. And here we have it. So start with the first one. The square root of 49 is actually equal to 7. And remember, we're not looking at the 49. We're not looking at the square root sign by themselves. We're looking at the value in front of us. And that value is the number 7. 7 is a counting number. So we start from the bottom of the tree and work our way up, or the center of the Venn diagram and work our way out. It's a natural number, which means it's also a whole number, an integer, and a rational number. Next one. 9.7 repeating, that's 9 and 7/9. And if I even want to improper fractionize it, it's 88 ninths. Let's see, 9 times 9, 81 plus 7, 88. Yes, 88 ninths. So that's a rational number. Because it's written as a fraction, it's rational. Repeating decimals can be written as fractions. We've covered that, and I'm going to be expecting you to know what your single-digit repeaters are. Remember, that's all your ninths. 0.1 repeating, 1/9, 0.2 repeating, 2/9, etc. Negative 55 over 5. When you divide that, you get negative 11, and that is an integer. It's negative, so it can't be a whole number or a counting number, but it is an integer, which means it's also a rational number. I could write it as a fraction. I could put a fraction bar under it and put the number 1 underneath it if I wanted to. All right, identify a number that is a rational number but not an integer. I decided to make sure that you recognize this concept to use all negatives here. These are all rational numbers, but not integers. So negative 4.7, negative 4 and 7/10. It's the 0.7 that makes it not an integer. The 0.8, the 4/5. Okay, which is the same number actually there. I didn't even really plan that. Just a coinky-dink. Last one, identify a number that is a whole number, but not a natural number. The only one is 0. He's the only one that's a whole number, but not a natural number. Try to think of him as the number with a hole in the middle. Maybe that'll help you remember. You can also remember that babies do not start counting with the number 0. 0, 1, 2. No, they don't start with the number 0. They 1, 2, 3, and so on. It doesn't make sense, the concept of 0, when you're, really little. All right. Next section. All right, again, going to pause it, going to write out the work, and then we'll go over it. Here it comes. And we're back. Okay, square root of 88. Square root of 88. The number 88 is between 81 and 100. So the square root of 88 is going to be between the square root of 81 and the square root of 100. So it's going to be between 9 and 10. And since 88 is only 7 away from 81, but it's 12 away from 100, it's closer to 9. Next one, 17. Well, 17 is between 16 and 25, so the square root of 17 is going to be between the square root of 16 and the square root of 25. So 17 is between 4 and 5, and it's a great deal closer to 16, so it's much closer to 4. Square root of 266, well, that's between the square root of 256 and the square root of 289, which is 16 and 17. And since 256 is only 10 away from 266, it's closer to 16. So these were all closer to the smaller one this time. And this is such a great concept for us to have down because we don't need to think about a calculator or anything. We're just talking about where's the number located. It's a good concept, math concept, instead of just an algorithm. All right, next section. All right, so we're working on our integer operations. Let me do the math out. Hopefully you've already done it when you're watching, and hold on just a minute. And there we have it. We've got our multiplying to start with. So negative 4 times negative 2 gives me a positive 8, times negative 6 gives me negative 48. So you have negative 48 for number 9. Notice that you have 3 negatives that you're multiplying, and so that's an odd number of negatives. That's always going to come out negative, and that's something we're going to look at with exponents in the coming classes. Next one, 72 divided by negative 4. 72 divided by negative 4. I don't necessarily want to do long division here. I don't want to necessarily do short division. I just want to remember that a fraction is a division problem and a division problem is a fraction. So all I'm going to do here is simplify like a fraction, because that, to me, makes the math easier and faster for me. If you've been using a calculator to do stuff like this, you're going to be sorely mistaken when it comes to your test, because I'm not letting you use a calculator at this point. I will, just not yet. We're not there yet, guys. Next one, negative 8 plus negative 3. Same sign, add and keep. Okay, same sign, add and keep. Number 12, it was negative 2 minus negative 3, which we rewrite with keep, switch, switch. So negative 2 minus negative 3 becomes negative 2 plus 3, which is 1. And I want to see that written on your problem. You are never, ever, ever going to change the sign of the first number. You're never going to change the sign of the first number. It's subtraction that has you switching the sign, not just arbitrary sign flippage. It's subtraction is, and we'll come back to this because that's the answer to number 14. We'll come back to that. All right, negative 8 minus 2, keep, switch, switch. Negative 8 plus negative 2, which is negative 10. So number 14, subtracting is the same thing as adding the opposite. Adding the opposite. 15, when you're multiplying or dividing two signed numbers, what are the rules for the results? Well, let's write it out in symbols. Okay? A positive times a positive is a positive. A positive times a negative, or vice versa, will always be a negative. It's when you multiply two negatives that you get the positive. Let's recall with a quick concept. If I reverse, negative reverse, charges on my account, I get my money back. All right. 2 more sections, I think. No, one more section. Fraction math. So let me go ahead and get started on these, and you'll see your answers momentarily. All right, finishing out with the fractions. Start with subtraction, and yes, I did this on purpose. We needed review with it. So we're subtracting 11.5 minus 4 3/4. And I want you to notice here that 3/4, oh no, Lecomte, you did the whole wrong problem. Okay, hold on, guys. Pause. Phew, crisis averted. Hopefully you didn't pause it and rush off to email me about my mistake, because I found it myself. So I accidentally made it 4ths instead of 5ths. So let's come back to this. So I'm already noticing 3/5 is bigger than a half. I know that because 2.5 is half of 5. So 3 is bigger than that. So this has to be bigger than a half. So I'm automatically going to have a problem with this example. So instead of stressing out and trying to do that borrowing stuff, I'm going to change them to improper fractions. Then I'm going to make a common denominator. Then I subtract, and it's, I think, a little bit easier. The numbers might get a bit on the large side, but 23 times 5 is not that stressful. Think 20 times 5, that's 100. 3 times 5, that's 15. Remember, you can do that math, whether it's on paper or in your head. It doesn't have to be done the traditional way that you learned. You can evolve. You can change. You can think it out differently. Multiplying mixed numbers, we make them improper fractions. We simplify a little because the numbers were quite large. 7 times 23, again, think that out in terms of 7 times 20, 140. 7 times 3, 21, 161. 161 over 10, easy, 16 and 1/10. 7 divided by a 7th. Whoop, I didn't mean to do that. Let me get rid of that because that's going to bother me. Neat. There we go. Pointer tool, please. 7 divided by a 7th. How many 7ths are in 7 whole things? That's the same thing as saying 7 times 7 over 1, or 7 times 7, which is 49. How many 1/7ths in 7? 49. 1 7/9 divided by 2. This time, I made the first one an improper fraction like I'm supposed to, but this time I used my common denominator method. Make this 18 over 9, put 16 on the top, 18 on the bottom, the 9s basically cancel, and then when we simplify it, we get 8/9. And that makes sense here, because this is 1 7/9 cut in half. Well, if 16/9 is the same thing as 1 7/9, half of 16/9 would be 8/9. Last problem is a word problem. Construction engineer said he needed 4 support pillars of equal size. He got a half ton of concrete. How much concrete did he use for each support pillar? I imagine some of you figured this out in your head, but if you didn't, let's talk about this conceptually. We have half a ton. We're dividing it by 4. So if I have a half and I cut it into 4 equal parts, each one constitutes an eighth of the original whole thing. If I'm not sure how to do that or think that out conceptually, 1/2 divided by 4 is the same thing as 1/2 times 1/4, which is 1/8. And that's it for your video, folks. Hopefully you feel ready for your test. Email me if you have any questions, and I'll see you in class.